Normally, in my international reputation for AI, I get asked to talk about this kind of thing. So, well, that's what sort of made my reputation. And so I'm just introducing this because we're in the ethics session, and I am going to, towards the end of the talk, kind of come back to this, and you'll see that some of my slides are kind of skewed towards this. Although I realize that's not the topic we're really talking about now. I feel like I'm getting a lot of feedback in the room. Am I really loud? I don't know. Okay, thanks. Okay, so this is the kind of thing I need to convince people. That artificial intelligence is already here. It's already changing what it is to be human. It's not something that looks like Arnold Schwarzenegger that may come in 50 years. Or it's something that's actually already affecting our society. And of course, deep learning isn't actually magic. It is not going to somehow spontaneously do my build here. Computation actually takes time, space, and energy. It's not math. And so knowledge is actually a resource that we've built up, right? And the thing that makes humans different from other species is we're really good at sharing the outputs of our computation, right? So we're both able to retain it, which is one of the advantages of being an ape, but all apes have culture, but we also have language. So we're the only ones who do, we're actually the only apes or monkeys that can do vocal imitation, which might be why we have this better form of communication. Anyway, why is this an advantage? Or another way to think about it is what is really actually hard about intelligence. The hard thing is something called combinatorics. So I'm doing this slide for the people here who are not computer science. Is there anyone who has no computer science degrees at all? Right, see, I thought so, because we're interdisciplinary here, right? Okay, so this is my general science one. It's basically like, imagine you had a robot and it can only do two things, move left, move right, or something. If it gets another chance, there's 4 different possible plans it could have had, right? Left, 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 right, 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 yeah. And you can kind of see how that goes. And you might think, well, this is a boring slide, but actually the whole point is you go from here to here in 9 months, right? It's inconceivable how much combinatorics explodes the space of what's knowable. And so when people are afraid of things like, the singularity, or that if China invests a lot of money that they'll have an unbeatable domination of AI, which if that was true, then America would already have an unbeatable domination of AI, right? So it's not, they're forgetting this kind of thing. There's actually more possible short, that 35 move chess games, than there are atoms in the universe. So there are more particles in the universe, subatomic particles, but not more atoms, all right? And obviously biology has a huge number more. If you don't believe me, go Google it, and there's like they have all the numbers there. This is a frequently asked question, because computer scientists always tell you this. All right, so the fundamental problem of search is combinatorics. As I said, there's always more to know, and machine learning exploits existing search. Those of you who are humanities people, I hope you realize I'm being slightly POMO here. All the talk up to here is sort of a talk about talks I normally give. We're about to switch into the one that I've gotten known for recently. Yeah, sorry, keep the laptops. I already said this, and I forgot the slide was here. I apologize. but anyway, you get to see the blue jays, baby blue jays. I also forgot I had the sound on. OK, so we might need the sound. Is there a thing for the sound? Mm-hmm. Yeah, OK. Oh, OK, great, OK. I don't actually want to do the sound right now, but I will come back to it later, possibly, depending on how fast this talk goes. This is typical of me. It's an hour talk. I'm trying to do it in half an hour. So anyway, yeah, AI is here. I already had this. I'm sorry. Let's get to the point. I totally thought I cut that out. So AI is just another way that humans process and extend the fraction of information we've been able to absorb into our culture. That's my claim. It's not some other alien force. It's something that we have. And that basically the reason machine learning is doing all these spectacular things is we've just gotten really good at uploading our existing culture into machines, basically. So machine learning is really, it's a programming technique. It's not something other than that. OK, and then, yeah, so now I can prove this because I got an article into Science. That's not really proof. Anyway, so now this is the main theme of the talk. So all the rest of that before was like I said, referencing the frame from which I normally come. OK, but now I'm going to do more like a science talk. OK, so what do words mean? One of the theories is that a word means exactly how it's used. All right, now that sounds super reductionist. I was just on the reductionist table here, right? But it actually can be useful, all right? What this means, among other things, is that you can understand the semantics of a word by looking at the context in terms of other words in which that word occurs. And you can do that with a computer. You can just count how often the words are sitting next to each other. All right? And this is how search works. That's how you can type 3 words into a browser, and it can come back with a web page that's closest to how those 3 words work. Now, of course, there's a little bit other magic soup that the companies have about like what people typically clicked on and whatever. So they do keep a lot of other data too. But the core technology is something called latent semantic analysis. So the question is latent semantic analysis really semantics? Is that really all there is? Can we actually come back to this really super reductionist definition of semantics? I think I've already just said this, so again, I'm going to skip over this. So it used to be that what people did was they used reaction time. Do you guys all know what a reaction time study is? Yes? No? Okay, raise your hands. I made the non-computer scientists raise your hands, the non-people who know what reaction time is, which basically means the non-psychologists. Right, a reaction time study is you're just literally seeing how fast people can push a button. All right, so you're measuring how long something takes as some kind of assessment of how hard it is for them. And we used to think that, although I have another entire talk about this, we used to think that that told you like how many cognitive steps they must be taking. All right, but that's not necessarily the only explanation for why it might take you a while to push a button, right? But anyway, we can use a reaction time study to see how quickly people are able to basically recognize one word when they've seen another word to indicate that those 2 words have similar semantics. And then we can use the computational linguistic stuff I told you of just counting words. And then, back in the 90s, we would get like, 76% correlation and say, oh, that's pretty good. Seems improbable. And then this is that. So if you're keeping track of the 75 words, like, so what you have a vector. You're just counting, did I see the word hat? Did I see the word scarf? Did I see the word, rhinoceros or something, next to the word I'm trying to understand, so square or something here. And back in the old days when we had small computers, you'd only do that for 75 words. And then you're just basically, but you then have a 75-degree space, basically, 75-dimension space. And you use a cosine to actually test what's going on, but you project it into 2D, and then you put it in your paper, and you say, oh, look, you can kind of see that sister and brother aren't too far away from each other, and And if you do use 3D, it makes it look even closer. But anyway, we don't do that anymore. This is the new thing we did for the paper, which instead of just using these weird reaction times that had been on this flashing words thing, we're using a really well-established psychological test, although people hadn't previously thought this was semantics. So this paper was kind of 2 things at once. First of all, I was checking, do you recover this information about how what humans think words mean when you do large-scale semantic analysis? So do the computers really have meaning? And secondly, is implicit bias just semantics? All right, which is actually the bigger question. That's actually the more profound question, but a lot of people have sketched over that. So anyway, the point here, now who has never heard of the implicit association task or implicit bias? Okay, all right, we've got a couple people. All right, so this again is a reaction time test. What you're trying to see, in order to see what your bias is about what 2 things seem to go together, we see how quickly you can recognize that those things have been paired versus not paired. And then so for example, in this case, we're looking for a bunch of words which are, books, words associated that are boys' names, words that are girls' names, words associated with math, and words associated with reading. And we can tell them that if you get the words matched up with, like boy math, you should go left, and girl reading, you should go right? But, or you could do boy reading, go left, and girl math, go right, okay? So the task is that the stereotype is that boys are more associated with math and girls are more associated with reading. But we're trying to see how quickly can a subject conform to the stereotype or break the stereotype and go the opposite direction. All right, so that's why you can see how this is. The first time I heard about this, it was actually Banaji giving a talk. and she drew a circle on the wall of like good, bad, bad, good, good, bad, bad, literally the word good and bad, and then told us to type our right hand with good and our left hand with bad, right? And then try it the other way around. It literally takes like twice as long. It's hard to type your left hand with good. And nobody, I don't know anyone who still thinks that the left hand is evil, right? That was in our culture thousands of years ago, but we had trouble typing our hand that way, right? Okay, so associated concepts are easier to pair, so you do it faster, and we just measure the reaction time. And yeah, this is a little bit more of the same thing. The basic idea is we're going to use a measure, which is we're not expecting that it's always going to be faster or slower, but we're going to look at the averages, and we're going to measure the distance between averages in terms of the standard deviation of the curve. So that means that how tightly this curve is determines how big of a deal it is if you're a ways away, right? So again, this goes back to how do you measure things in an independent way. And it's known, weirdly, some people still say, oh, the implicit bias is a fake result. It's fake science because it hasn't been shown to correlate with actual racism or actual sexism. But how you can call something a fake result, it's like the biggest, measures the D measure. That's like the biggest D measure in psychology. It's like one of the biggest, right? So anyway, all right, I want to emphasize this again. I'm not saying that two words next to each other mean the same thing. Artificial doesn't mean intelligence, but rather that you have a more similar context. Words that frequently, we often see artificial intelligence, artificial flowers, and that tells us there's some kind of commonality between intelligence and flowers that there isn't with some word you don't stick artificial in front of. Okay, so that's the concept of a word embedding. You're counting how often you see words next to each other. All right, okay. So this is what we're trying to use. What we took for the word embeddings was we didn't build our own. Partly what we say in the paper is we didn't want to introduce any bias into the stuff ourselves, so we used it all off the shelf. Of course, this is also faster because somebody else has done it for you. And we used two different ones. We used, in the main paper, you'll see GLOVE, which is Stanford, and the reason is because it used the entire English language web. And we needed that because some of the words that the psychologists had used were very low frequency. So we had to get like basically the whole web, honestly, in order to get some of the African-American names that were very low frequency. On the other hand, in the supplement, we do exactly the same thing. So both GLOVE and Word2Vec are not quite as simple as I just described we used to do in the 90s. So they're larger windows, and they've got weighting on them or whatever. But the point here is there's slightly different representations of those counts of the words next to each other. And they're completely different corpora. So the GLOVE is trained on, as I said, the whole English language web. And Word2Vec is using a corpus of Google News. And we still get the same results. In fact, the science copy editor said, why do you have the same table twice in your paper? Can we take one out? It's the same results. So anyway, yeah, that's the claim of off the shelf, right? So, which also means, of course, since this is off the shelf, that this is AI you can find in existing products. All right, so Grunwald et al. Are the ones who brought in the entire technique of the implicit association task. And they knew they were on something very big as well. So they started out with a gentle thing, and I'm going to do the same thing here. So they're looking to see if you think flowers are easier to associate with pleasant terms than with unpleasant terms compared to insects being associated with pleasant versus unpleasant, right? So this is often summarized as flowers are more pleasant than insects, but it's a little more complicated than that. Like I said, it's always a 2x2 test. All right, and so the original findings, and look, n equals 32. They only needed 32 people to get this, a D of like 7 is huge, right? So this is an incredibly large effect, and we also found the same incredibly large effect. Now notice, for us, our n is the number of words in the baskets, right? So it is like, you can't really say we replicated because we're doing something very different. We're not talking about the individuals, we're talking about the entire web. But the point is that you can recover in semantics this attitude about the pleasantness and unpleasantness of flowers versus insects. All right, so as you might guess, of course, the headlines are that there's also other things going on. And so we were able to replicate, again, replicate isn't quite the right word, the race. And also the first author, the postdoc, Eileen Kalaskan, had the idea, this is the study of where you send out resumes. You send the same resume, but you have African American or European American names, and you get 50% fewer invitations to interview if you have the African American name. So she took those names, and we had the same kind of, we also found the same kinds of results for those names. If you assume that you're more likely to invite people that are more pleasant, or more associated to pleasant. I mean, like I said, this is not exactly what I was talking about before. And also, there's no slide about this, but I have a blog post about this. This doesn't mean prejudice is true. Don't forget that right and left thing and good and evil. This is something about our culture. It's not something about like what actually is verbatim in the world. All right, so I'm happy to talk about gender because it's one of my own issues. So hopefully you won't be upset when I tell you that the internet trains semantic systems to believe that women are more associated with domestic words and male names are more associated with career words than the other, more easily associated than the other way around. And the same thing for science versus the arts. And we did every single paper that we could find in psychology that had words. They switched to pictures quickly instead of words. But that had words that were given to the entire, like people drawn from random parts of the country, rather than, like, we couldn't see just what part of the internet had been written by Korean Americans or something like that. So we couldn't do that. But for every single one, we matched it. And I want you to notice, to me, this would have been, if we'd just done the flowers thing, I would have thought that was a science paper in itself. Because we used to think you needed to have embodiment to experience the world to get the kind of viscera that we're talking about here. It's visceral to say that you prefer or that you find more pleasant flowers than insects, right? So that is embedded in that kind of experience is now, it no doubt derives from our physical embodied, experience, but it's now embedded in our cultural. It's if you can recover even using a dumb computer algorithm, right? An otherwise uninformed computer algorithm. And this is not in itself sort of AI because there was no action. We used it as a measure. It's just doing the perception. But it is embedded in things like translators and things like that do produce action. Anyway, the other thing, the final author, Arvind Narayanan, is up for tenure this year. So we were all kind of, although we thought this was a cool study we really wanted to do, we were all kind of freaked out by how strongly it looked like it could be like all the entire story of implicit bias. And so Arvind just said, I want to know how this compares to stuff I know is true. Well, again, where did Ken go? But what do we know is actually true? There's not that many things we really truly know. But one thing we know, or we can at least scrape, is the US labor statistics. Now unlike Ken, we only got 90% correlation here. But that's partly because what these dots represent are particular jobs. And some of them had more than one word, and we just sort of threw away the first word. So I think that's why we get some of these noisy outliers. But what this figure is on the y-axis is back to our measure again. So for each of these words, how male or female did it look? How closely did it go to the cluster of boys' names and girls' names? Again, we just used the ones that the psychologists had chosen in the first place. And on the bottom here is what proportion of people in the United States in 2015 that had that job were, in fact, female. Okay, that's the x-axis, 90% correlation. All right? So when I say at least, actually this is now the same as the final paper. Sorry, this is a version of the talk from when we still had the archive. So when machine learning people talk about bias, we mean basically knowledge. It's stuff you extract, right? And you need bias to learn anything at all. You need priors, right? It's also like in AI planning, we talk about constraint, and constraint is a good thing because otherwise those combinatorics, that stuff at the beginning I was talking about, they're just overwhelming. So you need to constrain your search to something that makes sense. And when you're trying to learn, you constrain it with bias. That's what you use to constrain it. And it's regularities you detect, and that's what we use machine learning for quite often, is to detect regularities. So that is the technical, not the sort of folk psychological meaning of the word bias. The technical, as I understand it from sociology, use of stereotype is these things like that we were just talking about. So if you looked at these papers, when they talk about the implicit bias test, the sociologists would have been happier if they'd called it the implicit stereotype test, right? And what we're suggesting in our paper is that given this correlation with reality that we discovered, which was not part of the original idea of the study, we think that that we can now define stereotypes as biases that are based on regularities that are out there, but that we don't want to persist. Society has signed up and renegotiated a better equilibrium, and we say, we want everybody to be able to have a career, not only men, right? So this is where I think a lot of the biases are coming from. And then prejudice, having a stereotype, and this is going back to the people who say, oh, this is junk science, I'm not actually racist or whatever. Having a stereotype is not the same as being prejudiced. Prejudice is actually acting on the stereotype, so actions can be prejudiced. And that's where you have a problem, okay? All right, so yeah, the examples here. So expectations derived from experience are knowing that a programmer means, and that turns out to also include that most of them are male, because most of the ones you've seen were male. But a stereotype would be that this bit of knowing that most programmers are male. Prejudice is hiring only male programmers. Or even saying, which one of my favorite books, The Mythical Man Month, but saying Mythical Man Month, saying the programmer he, right? That's a prejudice, but back when Fred Brooks wrote that book, it was the standard English, all right? Okay, so, so critical implication here is that stereotypes are culturally determined. It's something we've negotiated relatively recently. You can't get them from just looking at the world. So we don't think there's a way using machine learning to pick up and discriminate the stereotype from ordinary bias. We think that's something you have to program separately. And so the implications here are that AI that is based on machine learning, that is programmed using machine learning out of human culture, isn't going to be somehow neutral. I don't even know what that would mean when you really think about it. Like what totally neutral would probably be back to entropy again, right? But so yeah, and this goes back to the computation thing. The argument I made at the beginning was not only to show you the direction, it was also to get some important ideas across. So we suggest that when we construct AI systems, like really AI that's going to take an action, we need to bootstrap off of real semantics, really understanding, well, depending on what you're trying to do. If you're a thermostat, you don't need any of this. But where we need to have stuff that's more easily programmed with machine learning off of culture, we should also have a second system that filters it out, basically. So yeah, sorry, I forgot what the next build was. So this may sound like I'm saying that you have to build consciousness into AI or else you shouldn't have it be there. But you can think of this in terms of just text prediction. So you could say that the latent knowledge is the entire dictionary, so you could predict any word out of the dictionary. And then you have a relatively short list of terms that you're not going to predict, even if you know for a fact they're typing it. You're not going to predict it because that would be rude, and probably, even if they did mean to be rude, they don't want to know, right? So it's not that hard to compartmentalize AI this way. It's just a simple architecture structure. Also, interestingly, we have a new null hypothesis for human prejudice, which is that it derives from observed regularities, which I think you guys are smart enough that even though I was in a hurry, I thought I'd better cover this part too. So what does all this say about racism if I was saying it has something to do with veridical? I think what's going on is that it's a special case of parochialism, and that's why I brought up that example before about Korean Americans. So Greenwald et al., again, had exactly the same problem we have. In fact, this is just their problem. We've just shown it's in AI. But it's us as a culture. We all have. I don't mean it's their problem. Anyway, the point is that Korean Americans find Japanese names less pleasant, and Japanese Americans find Korean American Korean names less pleasant. And so that kind of makes sense. It's basically saying, like, I like being me, right? That's great. But unfortunately, African Americans show similar, although not as strong, actually, associations as European Americans. And so we have a hypothesis. We haven't gotten there yet. It's like a year later. We still haven't done this yet. I'm sorry. I've been flying around doing meetings like this. But race is just one identity indicator, and what's really going on here is identification with the dominant cultural group is pleasant. I think that's probably what's happening. And incidentally, this is our one little bit of study we've done so far. I think Eileen and Arvind got to some other thing, but I haven't even had time to read it yet. But this is the first thing we did. Frequency accounts for a lot of the data, but again, then you have a really interesting question of why do people choose really low frequency names from some groups. But also, now this is based on the callback percentage. So Eileen wrote to those guys that did that resume study, and they got the actual callback study value per name. And so the best predictor was not how African American is. I don't know how she checked that, but actually how pleasant it was. So pleasantness was the best predictor. But look, a lot of this is just coming down to frequency too. So how familiar was it? But again, I think familiarity is one of those indicators of in-groupness. Okay, so how should we address machine or implicit bias? I already told you this, actually. I can go fast. Yeah, don't worry about consciousness too much. Oh no, I forgot what am I doing. All right, I did already talk about this. So the implicit knowledge and the explicit knowledge, right? So yeah, so explicit knowledge is associated with deliberate control and negotiations to rapid progress. Okay, and this is what we argued in our paper. Another paper hit arXiv the same time in 2016 and went into NIPS 2016. These guys have been working on theirs for years too. I'd actually been doing this work with undergraduates at Bath for years, but they do it way better at Princeton. It was much better. No offense to Bath undergraduates, they were awesome too. Actually, we're still hoping to get another paper out of that. Anyway, sorry, I'm just digging holes here. These guys said, hey, sexism is horrible. Let's flatten the representation so all the male terms, all the female terms are equal. All right, and they did it. I mean, they went to some huge amount of effort and did it. It took them years. But I don't think you can get everything out of that. There's all kinds of isms that we don't even necessarily realize the prejudices that we have. And also, as I said, there's so many questions that come out of this. You're reducing the ability to communicate because now the AI system has a different representation than society has. And who gets to choose what the representation should be? There are large sectors of, I'm sure, every country's population who still think that women should be more domestic, right? Including some women, right? So making those decisions, I would rather that we work on society and then keep the AI turned on. I totally agree with the people who say we don't want to get a snapshot now because we've just developed machine learning and then try to hold the present as the expectations we have, for example, about who's going to go to jail and things like that, right? All right. So yeah, I have a question, which is how much time do I have left? Where's my chair? You.
5 minutes.
Okay. I have so many other slides I could show you. So I think I talked about this before, or right towards the beginning, that just because machines are sharing our prejudice doesn't mean that we need to treat them like other humans. Actually, it means that they're an extension of our culture, all right? And this is incredibly hard to get across. So many people, again, and I think this paper actually helps me understand why we have so much trouble. You know that slide I flipped through before about intelligence? We think of intelligence as being correlated with human. And humans are the moral subject. So then we think if you're intelligent, that means you're moral. I just yesterday found out about some paper, I think it was at dinner, somebody told me about a paper where everybody assessed things to be either intelligent, the intelligence is either 0 or 1, and it was 1 if, it was David, but it was 1 if it was human-like, right? We just think intelligence means human-like, and we don't think of it as meaning, being able to do the right thing at the right time, so like a thermostat. So trying to get this across is very hard, but you do not get to author your child. Yes, it matters how you raise your kid, right? But you don't get to choose, how many limbs she has or whether she uses laser, to figure out how far away things are. And you don't get to choose the fact that if her classmates socially exclude her, she will have lower expected health, lower expected vitality, right? It will change who she is if she's socially excluded. And you don't get to choose that. That's what it is that would be true of a fish too, incidentally. Like, well, not classmates, but a fish that is socially excluded is going to be worse off, and probably was already bad off if it was excluded, but you get what I'm saying. The point is, you cannot conceive of how much stuff is already there in the genes, right? And it's just different from starting from scratch. I don't think I want to do these slides. But this is what people are implying, and some people feel very strongly about, that we should build AI and then project our culture out there because, hey, humans are flawed or something. I don't think this makes sense at all. I think that, I've tried, because, hey, I'm a sci-fi, who put up Star Trek? That was awesome. I love Star Trek, right? You know, I'm a huge sci-fi geek. But our entire system of aesthetics and values is based on trying to build societies so that we could, dominate the world. I mean, or at least stay alive and persist, right? So I don't think there's a set of values by which it makes sense to eradicate our species or to divert resources from our species into machines. I think we should see machines as an extension of ways of enhancing humanity. But that's not something I can prove. But I can get involved in policy recommendations, and this is just one. Yeah, so I'm going to skip over this, sorry. Congruent with the previous talk. So yeah, artificial intelligence and natural intelligence are continuous with each other. Neutral magic fairies of mathematical purity are not going to fix our problems. We actually have to fix them culturally. All right. And it has to be biased, as I said, because of these things. And this would be a really good place to end the talk, but I did want to point out that not all bias comes from automatically. Some of it comes from insufficiently diverse teams. But what I worry about the most is that all of this is like frou-frou, I guess, in the New York Times, and meanwhile, you can just elect a government that says, by the way, we don't like immigrants to get any of our resources, or we don't like a particular ethnicity, and so we're just going to bomb them if they vote the wrong way. Turkey did that. Can you imagine bombing part of the country just because they started voting for the wrong party? I mean, that's, anyway, we're ignoring a lot of stuff, arguing about whether AI is sentient. So one way to fix all this stuff is, as I said, we can't really do that much except compensate with architecture. But with the ignorant stuff, all we have to do is keep iterating and improving. And we can do better than we did before. For those of you who are computer scientists and hate regulation, I think we're just growing up. We are more important. The stuff we build as toys, like Facebook, is actually now critical infrastructure. We didn't mean for it to be, but it just is. And so now we've got to be like the architects, and we have to deal with and enjoy working with the governments, and because we are changing the world. But so when we design our tools, we need to actually start engaging as the architects had to. The architects didn't used to. They used to just be rich people that went out and built buildings that sometimes collapsed on people. Eventually, society got organized and said, you can't do that anymore. And now they are really well integrated into government. We need to be too. People are going to get tired of AI falling on them. So, okay, I think I should probably stop. But this is an amazing article. You got to see this. But I'll skip over this. Yeah, I'm going to skip over that. Yeah, and yeah. So privacy, right? Okay, we know this. And this. The last thing I'm going to say is I just had another paper come out. I think it's really awesome. So in case you either agree or disagree with me, I'm hoping that you'll cite this paper and send it. And if you agree with me, you'll send it to your legislators. It just came out last weekend. Okay, thank you. Sorry about that long end.